Remember when we multiplied decimals, we really had two tasks. We were identifying the digits involved, and then we identified the position of the decimal within those digits. Well, a similar thing is true in dividing decimals. That is, we have those two tasks to perform. We want to identify digits and we want to identify the position of the decimal. But with dividing, we actually end up identifying the position of the decimal before we end up dividing. Here's what I mean. Suppose we want to take this number and divide by that number. Well, let's set up the long division. We're dividing by 3/10, and we're dividing 3/10 into 57/100. So we have this. Now, we place the decimal up here in the position for the quotient before we even start the division process. Now, we don't have to do it that way, but it's customary to do that, and it's really easy to do. Here's how we do that, and I'll show you the mechanics of it, and I'll tell you why it works in just a minute. But the mechanics of it works like this. We say to ourselves, we can only divide by whole numbers. That's not true, but we say that just to place the decimal. All right, if we can only divide by whole numbers, to make this whole number, we'll move this decimal one place to the right. But if we move this decimal one to the right, we have to move that one to the right. And now, once we have moved it one to the right, we go straight up into the answer. You see, so this is just a little technique for placing the decimal into the answer before we even start the process of dividing. Now, the reason we can do this is this. Recall that when we were dealing with fractions, I can make a fraction out of this situation. This is 57/100 divided by 3/10, like this, as a fraction. And you know that if we multiply fractions by forms of 1, that we don't change the value of the fraction, we simply change its form. So what if I decide here to multiply by 10/10? Now 10/10 is 1, so I'm multiplying here by a form of 1, but look at what happens when I do that. I've got 0.57 times 10, decimal moves one place to the right, so this is really 5.7 for the numerator. And in the denominator, 10 times 3/10, this decimal slides 1 to the right and we have 3. Well, look at this. This is 5.7 divided by 3, you see, which is what we have here once we slide the decimals over one spot. So this is what allows us mathematically to do what we're doing right here. And we're only doing this to make sure that the decimal falls in the right spot in the answer. All right. Now, once we've done that, once we go through that little routine, we divide as we normally would. That is, as though there were no decimals involved in the problem. We don't really have to worry about the decimal anymore. 3 into 5, let's see, goes one time. 1 times 3 is 3. Draw the line, subtract, we get 2. Bring down the next digit. 3 into 27 goes 9. 9 times 3, 27. The division goes evenly, so we're finished. Our answer is 1 9/10. Consider this problem. We have 3/10 that we're dividing into 2 3/10. We go through that little routine of placing the decimal. This one slides 1 to the right, and therefore the decimal here slides 1 to the right, and then straight up into the answer. We just place that decimal up there, and away we go with the division. 3 into 2 won't go. 3 into 23 goes 7. 7 times 3, 21. We subtract and get 2. Now, when we went through long division and we were talking about fractions and mixed numbers, remember that at this point in a problem like this, we would put the remainder over the divisor, and we would write this as 7 2/3 without the decimal point. And we could actually do that here. But we're dealing with decimals in this chapter, and so we want to stay in this decimal format. So we'd like to express our answer as a decimal number, not as a mixed number, you see. So the way that we continue the division is that we just tack on a bunch of zeros, as many as we'd like, to the right of this digit. That is, we tack on a 0, maybe several of them here. All right, and then we can go about the business of continuing the division like this. Bring down the next 0. So we have 3 into 20 goes 6. And I'll just extend out here. 3 into 20 goes 6. 6 times 3, 18. Subtract, I get 2. Bring down the next digit. You see, now I'm dividing 3 into 20 once again. I divided 3 into 20 right here. I got 18. Same thing's going to happen right here. 3 into 20 goes 6. 6 times 3 is 18. Subtract, I get 2. No surprise there. That's what happened before. Bring down the next digit. You see, and I would go through this again and again and again. In fact, I would go through it until I get tired, or until I run out of paper space, or until I get older, or whatever. But I have to decide when to stop. And usually you stop because you want to round the answer to a certain position, to a certain amount of accuracy. Now, in rounding, the process of rounding involves looking at the next digit. So if I were going to round to the nearest hundredth, this is the hundredth digit, I would need to look at the next digit. Well, I don't yet have that next digit to look at. So I would have to carry my division process out far enough to where I can look at the next digit so that I can round to some target. All right, I'll take that division out that one step farther just by continuing here. 3 into 20 goes 6. 6 times 3, 18. I still get a remainder, but that doesn't matter. I have my digit to look at here, and therefore I can round to the nearest hundredth. And to the nearest hundredth, let's see, this is a 6. Number 5 or larger, so I'm going to make this one bigger and then lop this off. So this is 7.67. 7.67 is the answer. Rounded to the nearest hundredth. Now, a rounded number is not an exact value. It's not the same as 7.6666666 forever, you see, because I rounded it to some degree of accuracy. And it's kind of important to realize that, and we'll have more to say about that later on in our studies. Okay, so 7.67. Let's go through the process again. We have, let's see, we want to divide by a whole number, so we're going to slide one place over. We're going to slide one place over straight up into the answer. And away we go. Now, if this one doesn't turn out to be, to go evenly, then let's decide ahead of time that we're going to round off to the nearest tenth. And if we're going to round off to the nearest tenth, it means that we need to carry our division so that out far enough to where we have a hundredth digit. All right, so understanding that, let's go. We have, let's see, 81 into 529. I'm thinking about 8 into 52, which goes 6 times, you see, as a key to help me decide how many times 81 goes into 529. Remember that from whole numbers. So 81 into 529 probably goes about 6. Let's see. 6 times 1, 6. 6 times 8, 48. 9 minus 6, 3. 2 minus 8 won't go. Can't take 8 from 2. I borrow from the 5. It becomes 4. The one that I borrow makes this 12. 12 minus 8, 4. The 4 is 4 minus 4 is 0. Okay. I've subtracted. I've gotten 43. The division didn't go evenly, so I need to tack on some zeros. Now, how many zeros do I need to tack on? Well, if I'm going to carry the division out far enough to round to the nearest tenth, then I need a hundredth digit, so I need a 0 right here to continue my division out that far. So that's why I added 2 zeros and not 1 or 3. All right. Now I bring down the next 0 and continue the process. 81 into 430. I'm thinking about 8 into 43. Oh, that would be 5. So let's try 5 here. 5 times 1, 5. 5 times 8, 40. Subtract, let's see, 5 from 0 won't go. Borrow from the 3, it becomes a 2. The one that we borrow makes this 10. 10 minus 5, 5. 2 minus 0, 2. We're okay here. All right, so 25. Bring down the next digit, 0. 81 into 250. I'm thinking about 8 into 25. 8 times 3 is 24, so I'm going to put a 3 up here. 3 times 1, 3. 3 times 8, 24. Let's see, 3 from 0 won't go. Borrow from the 5, it becomes 4. Making this a 10. 10 minus 3, 7. 4 minus 4, 2 minus 2. Okay, 7 is the remainder here. But I don't really care so much about the remainder. I just want to make sure that I've done the right thing in division. If my remainder happened to be greater than the divisor, you know, that it would go one more time, that this digit could be one larger, and all of those techniques come into play here. But with this remainder, I'm not going to worry about that anymore. I've done the division properly up to this point. And now, to round my answer to the nearest tenth, I look at the tenth digit, I look at the digit to the right of the tenth digit, it's smaller than 5, I just lop it off, so this is approximately 6.5. So my answer is 6.5 to the nearest tenth. Here's a situation involving 10 as a divisor, And we're going to look at a little technique here that's kind of similar to the technique in the last section where we talked about multiplying by 10 and 100 and 1,000. And remember, the answer, we could find the answer really quickly just by sliding the decimal point one way or the other in this case. Now, we slid the decimal to the right when we were multiplying by 10. It's going to turn out that the decimal slides in the other direction when we're dividing, and that's not really much of a surprise, is it? I want to show you why it works that way. 10 into 25, well, let's see. Now, let's place the decimal in the answer first. I'm kind of getting ahead of myself here. The decimal is understood to be to the right 10 here. We don't need to move it, therefore. So the decimal that's here goes straight up into the answer. All right, 10 into 25 goes 2 times. 2 times 10, 20. Subtract, we get 5. Bring down the next digit. 10 into 54 goes 5. 5 times 10, 50. Subtract, we get 4. Let's carry the division one more place. 10 into 40 goes 4. 4 times 10, 40. And now the division has gone evenly. And our answer is 2.54. Now, look at what we were dividing into. We were dividing 10 into 25.4. And our answer is 2.54. Now, the digits are the same. The difference between these two is that this decimal has simply moved 1 to the left. You see, moved 1 to the left, and there's 1 0 in 10. So that's the pattern that we want to establish here. It's the idea that if we're dividing by 10, the decimal slides 1 place over. If we're dividing by 100, it'll slide 2 places over. If we're dividing by 1,000, it'll go 3 places over to the left. Now, another way to show this, by the way, is like this. This is really just 25 and 4/10 divided by 10, like this. You see, and we can come directly to an answer by saying when we divide by 10, we slide that decimal 1 to the left. This is just 2.54, and we don't need to go through all of this business. We know we can predict the result. All right, let's take another one. Here, 100 into 25.4. Very similar idea. We can go through the long division process. The decimal goes straight up to the top. We have 100 into 254 goes 2 times. 2 times 100 is 200. With 54 as the remainder. Bring down a couple of zeros here as placeholders for us to continue the division. We bring down the next 0. 100 into 540 goes 5 times. 5 times 100, 500. Subtract, we get 40. Bring down the next digit. 100 into 400 goes 4 times. 4 times 100, 400. The division goes evenly, and we're verifying here that when we divide by 100, we slide the decimal 1 2 places to the left to get our answer. And it's often the case that we would put a 0 to the left of the decimal if there's no other number there. So the idea is that if we had 25.4 and we were dividing by 100 like this, we would just say, well, the easy way to do this is to slide the decimal 2 places south. And to do that, we just slide it to this position and write 0.254, and we would probably tack on that 0. Now, we know we can extend the idea, once again, to the notion of exponents on 10. That is, 100 is 10 squared. So it should make some sense. Excuse me a moment. It should make some sense that if I had written 100 as 10 squared, you see, then I could see this situation just as easily as I could when it is 100. I know that the exponent on 10 corresponds with the number of zeros that will follow 1 for this number in the denominator, and therefore it corresponds with the number of places I'm going to slide that decimal point. So I need to slide the decimal point 2 places over. Now that allows us to solve problems like this very quickly. 7 and 4/10 divided by 10 squared. 10 squared is 100, 2 zeros. The 2 is right here in the exponent, so we're going to slide that decimal 2 places to the left. So we slide this decimal 1 2 places to the left. Oh, we need a placeholder here. So it's going to go, now you can emphasize the idea, and I suggest you do this when you do it the first few times. It's going to move to that position, you see. And we can see then that we need a placeholder. So we're going to have a decimal and then 074. And now we can tack on that 0 to the left of the decimal if we'd like to do that. And here, 25 divided by 10 cubed. 10 cubed, 3 zeros will follow the 1, you see, for this number. It's 1,000. So we're going to move the decimal 3 places to the left. The decimal is understood to be in this position. So we're going to move 1, 2, 3 places to the left. Once again, we need a placeholder, and we can emphasize the idea like this to show that it's moving over 3 places to this position. So we need 0.025, and once again a 0 to the left of the decimal. Here's a word problem. It says a case of cola costs $6.79. There are 24 cans in a case. Find the cost per can. The cost per can. A lot of times the word per in a problem gives us the notion of division. Cost per can means take the cost, take the total amount of money, and divide by the number of cans. Cost per can is $6.79 divided by 24. Cost per can. All right, so it's 24 then into 6.79. Now, let's say that we're going to round off to the nearest penny. If we're going to round off to the nearest penny, that's to the nearest hundredth now. So we would need to carry our division out to the thousandths place if it doesn't turn out to go evenly. So let me go ahead and add that thousandths digit. You see, just in case we're going to round off, or just in case the division doesn't go evenly. So we're going to divide 24 into this. The decimal goes straight up because we don't move here. We don't move the decimal any right here. We're dividing by a whole number. The decimal then goes straight up into the answer, and away we go. 24 into 6 won't go. 24 into 67 goes 2 times. 2 times 4, 8. 2 times 2, 4. Draw the line and subtract. 8 from 7, oh, it won't go. Borrow from the 6, it becomes 5. The one that we borrow makes this 17. 17 minus 8 is 9. 5 minus 4 is 1. Bring down the next digit. So 24 into 199 goes, let's see, I think 8 times. 8 times 4, 32. Carry 3. 8 times 2, 16, and 3, 19. Subtract, I get 7. Okay, now I need to carry out, it doesn't go evenly here, so I need to carry that division one more time. So I'll bring down that 0 and I say 24 into 70. And that goes about, looks like, maybe twice. So 2 times 24 is 48, and I subtract just to verify that the division is done properly. I'm borrowing from the 7, it becomes a 6. The one that I borrow makes that 10. 10 minus 8 is 2. 6 minus 4, 2. Wow, this is almost as big as the divisor, but not quite. So I've done the division correctly up to this point. I'm rounding to the nearest hundredth, so I'll look at the next digit. It's below 5, so I just lop it off. So this is 0.28. Now, we were talking about the cost per can, so we need to write our answer in terms of a cost, in terms of an amount of money. And 0.28 is 28 cents, so this is our cost per can, 28 cents per can.